Hello everyone, I am Saharsh Agrawal from first year IIT Kharagpur and I am here to demonstrate an exciting experiment to you all. We will be proving the Pythagoras theorem using real physical objects. For those who have forgotten or don't know, the Pythagoras theorem states that in a right angle triangle ABC, which is right angled at the angle B, the side AB, the side BC, and the side AC are related as AB square plus BC square is equal to AC square. So the sum of the squares of the base and the perpendicular is equal to the square of the hypotenuse. If we see around us, there are so many applications of the Pythagoras theorem in real life. We can use it to calculate the length of the staircase required to reach a window, length of the longest item that can be kept in a room, steepness of hills and mountains, and it is even useful for two-dimensional navigation. We will be needing the following materials to do this experiment: one blank A4 sheet, one colored paper, one pencil, an eraser, a ruler, a pair of scissors, and some glue or gum. On the colored paper, draw four rectangles, each having a length of 4 cm and a breadth of 3 cm. Draw any one diagonal for each rectangle. Cut out the rectangles using scissors and also cut through the diagonal. Thus, we will have 8 right angled triangles with perpendicular sides of length 3 cm and 4 cm and a hypotenuse of length x. Then, on the blank white sheet, draw two squares of side 7 centimeters and we can call it PQRS as seen in this slide. Inside one of the squares, paste any of the four cutout triangles such that the triangles cover some area of the square, leaving space for two squares of side lengths 3 centimeters and 4 centimeters respectively. In this figure, we can see how the triangles are to be pasted. Inside the other square, we can paste the remaining four cutout triangles at the corners of the square such that the triangles touch the entire perimeter of the square, leaving space for one square of side length x in the center. This square is formed by the hypotenuse of the triangles. Now that we have pasted the triangles, here are a few interesting things to observe. If we calculate the remaining white area in both the cases, white area in case 1 is equal to area of square PQRS minus 4 times area of triangle ABC. White area in case 2 is equal to area of square PQRS minus 4 times area of triangle ABC. Since the area of the square PQRS and the area of the triangles ABC are constant in both the cases, that means that the white area in case 2 should be equal to the white area in case 1. Hence, we can equate their values. Value of white area in case 1 is 3 cm square plus 4 cm square because we had two squares, one of side 3 cm and one of side 4 cm. The value of white area in case 2 is x square because the white remaining area had the length x centimeters. Thus, 3 cm square plus 4 cm square is equal to x square, where 3 cm was the side BC, 4 cm was the side AB, and x was the hypotenuse AC. Thus, in the right angle triangle ABC, right angle at the angle B, AB square plus BC square is equal to AC square. Hence, we have proved the Pythagoras theorem. Here is a short animation for you to better visualize what we have just done. So let us take a blank square PQRS of side 7 centimeters. As mentioned in case 1, let us paste the four triangles in their proper places. So as we can see, we have pasted the four triangles, which leaves two squares as empty spaces, 4 centimeters and 3 centimeters sides respectively. And so instead of making a completely different square and pasting four more triangles on it in different positions, what we can do is we can animate this and simply move the triangles from one place to another without adding or removing any triangles, like covering the entire area of the square and without letting any triangle go outside of the square or anything like that. So let us do that. So let us bring this triangle down here, this one towards the left and this one towards the right corner. So as you can see, we have not added or removed any triangle or have left any extra spaces or have done anything. We have just moved the triangles, and this is the case 2 that I had shown before. So as you can see, now we have the following dimensions: 4 3 4 3 4 3, which add up to 7 on each side, and thus we can see the triangles are the same, and this is the square that is left of x centimeters length,
We have just moved the triangles. We have not added or removed any triangles. So
The area of the white square should be same in both the cases. In case 1 we had two squares of 3 centimeters and 4 centimeters length, and here we have a square of x centimeters length. Their area has to be the same.
So that is how the Pythagoras theorem can be proved visually.
Thank you so much for your kind attention. I hope you all have enjoyed this experiment and have learned something new, and now have a better understanding of the ever important Pythagoras theorem. Thank you.